When you hear artificial intelligence, what image first pops into your head?
Uh-huh.
For many, it's straight out of science fiction, world-controlling supercomputers, sentient robots.
Right, the stuff of blockbusters. Either saviors or, well, our doom.
Exactly. That media picture is incredibly powerful, isn't it?
It is. But it often paints a very different picture from the reality of AI today.
Yeah.
Leads to some pretty wild expectations, I think.
And that disconnect is exactly what we're diving into today. We want to cut through the movie magic,
Mm-hmm.
Understand what artificial intelligence actually is. Why does it matter in your daily life? How does this technology really work under the hood?
And where is it being used? Sometimes in surprising, almost invisible ways.
Yes. And just as important, what are its real fundamental limitations? What can't it do?
Our guide for this is the book Artificial Intelligence by Dr. Joseph Tegus-Santoso. It gives a great roadmap.
It does. It starts with definitions, then dives into data, algorithms, the hardware.
Right, then applications, and importantly, where AI, well, fails or hits its limits.
So our mission is simple. Get to grips with what this technology truly is and what it can really do for you. Let's unpack this.
Okay.
Okay, so starting at the beginning, how do we even define artificial intelligence? The book says it's essentially intelligence added to a system.
Intelligence that can be studied and regulated scientifically.
Mm-hmm.
Or you could just think of it as the intelligence of a scientific entity.
That definition feels a lot less apocalyptic than the movie versions, doesn't it?
It really does.
Yeah.
And that's the core issue the book brings up, that huge gap between the sci-fi portrayal and the technical reality. It creates false expectations.
Absolutely. And we tend to do that thing, right? Give human traits to technology.
We anthropomorphize it, yeah.
Right.
We expect it to think and behave like us, but it's fundamentally a tool, a technology.
The source gives us 4 really helpful ways to think about defining AI, showing it's not just one thing.
Right. It depends on the goal. Is it aiming to? 1, act humanly.
That's the Turing test idea.
Exactly. Can it fool you into thinking it's human? Needs things like understanding language, knowing stuff, reasoning, learning.
Okay. Then number 2.
Thinking humanly. This is more about cognitive modeling, trying to replicate how the human mind actually works, using brain scans, psych tests, that kind of thing.
So mimicking the process, not just the result.
Precisely. 3rd is thinking rationally.
Mm.
This is about pure logic, following rules to solve problems logically. Though the book notes it's often harder to build than to describe logically.
Makes sense. The real world is messy.
Which leads to the 4th one, acting rationally. Doing the right thing given what it knows to get the best outcome. This is where it often differs from us because we use instinct, intuition.
The self-driving car example from the book really clicked for me here. A purely rational car would just follow the laws perfectly?
Yes, strictly by the book. But the source points out, human traffic isn't strictly rational.
Huh. No kidding.
People speed, merge weirdly. So for an SD car to work, it needs to act rationally within that irrational context. It needs to be more, well, human-like in its actions, even if it's based on rational calculation.
That makes perfect sense, navigating reality. The book also mentions other classifications like strong versus weak AI.
Yeah, those terms can be a bit fuzzy.
Yeah.
Weak or narrow AI is mostly what we have now, is systems good at one specific thing, like playing chess or recognizing faces.
And strong AI.
That's the hypothetical, human-level intelligence, something that could do any intellectual task a person can. Still very much science fiction for
That's
now.
fair.
Artificial general intelligence, or AGI.
So this idea of creating intelligent machines, it's not new at all. The book mentions ancient idols.
Right. That desire to give intelligence or life to inanimate things is, well, ancient.
But the scientific pursuit has had its ups and downs, lots of early excitement.
Oh, immense optimism. Mid-20th century, people genuinely predicted human-level AI within a generation.
Which didn't quite happen.
No. And the book makes a good point. It wasn't just that computers were slow, though that was part of it.
Like Turing needing that repetitive phrase to crack Enigma faster?
Exactly. It was also a fundamental misunderstanding of just how complex human intelligence really is, how hard it is to replicate.
Then came expert systems in the 70s.
Right. These were rule-based, trying to capture human expert knowledge in narrow fields, using small knowledge bases. By the 90s, they were often seen as a bit of a failure.
But the source argues that's not the whole story. They didn't fail, they just disappeared into other things.
That's the AI effect again. When something works reliably, we stop calling it AI Think grammar checkers.
Writer was the example, started standalone, then got built into word processors.
Exactly. We don't call spell check AI now, do we? It's just
Hmm.
expected.
And this cycle of hype, then disappointment, led to the AI winter.
Yeah. Periods where funding dried up, interest cooled off because the promises were just too big, too unrealistic. It actually slowed down real progress sometimes.
So, after those winters, what sparked this current AI spring? What's driving the buzz now?
In a word, machine learning. That's the big driver today.
Okay, machine learning. Break that down for us.
Think of it like teaching by example, not explicit instructions. Instead of coding rules for cat, you show the computer thousands of cat pictures, thousands of not cat pictures.
And it figures out the patterns itself.
Exactly. It learns, like teaching a baby almost.
And I suppose, just like with a baby, if you show it bad examples.
Precisely. The book stresses this. Careless teaching, meaning flawed or biased data, leads to the machine learning the wrong things, problematic patterns.
Which brings us to data. Data is the new oil. Clive Humbleby gets the credit.
Yes, and it really captures the value. And we're just swimming in data now. The big data revolution isn't hype, it's daily life.
The numbers are insane. 2.5 quintillion bytes a day, most of it unstructured like video, audio.
And crucially, it's data about us. Our activities, feelings, interactions, pouring in from web searches, social media, phones, listening for OK Google, sensors everywhere.
Automated collection happening all the time.
And the book hammers this home, just having tons of data isn't enough. Current AI can't just magically find insights in raw, messy data.
Needs cleaning, organizing, separating signal from noise.
Enormous amounts of work. And the data itself poses huge challenges.
Like getting reliable data. The Kansas abbreviation example was great. CAN, CANS, KS, KA.
Nightmare for a computer expecting consistency, unless you've meticulously cleaned it.
And missing data, that's tricky too.
Yeah. Is it missing randomly, or is there a pattern?
Okay.
Simple fixes like using the average often aren't good enough. Then there's misalignment at different formats, different standards, and just figuring out what's actually useful versus noise.
The book mentioned 5 data fallacies too. Commission, omission. The frame of reference one stood out.
The sailor in the storm example. You can describe it, show videos, but if you haven't experienced
You
it,
lack the context, the real meaning.
exactly. That experiential knowledge is incredibly hard to capture for a machine.
So it sounds like a lot of AI failures aren't the algorithm's fault, but the data's.
That is exactly the point the source emphasizes. A perfect algorithm-fed bad data gives bad results. Asking the right questions, using the right data, processed the right way, that's fundamental.
And that insight from Wisner-Gross that data is driving success more than new algorithms.
Yeah, it's a powerful argument. Many core algorithms are actually quite old, maybe 15 years older than the data on average. The breakthroughs come from having the volume and quality of data, plus the hardware to actually process it all.
Okay, so let's talk about that processing, the algorithms and the hardware. What are algorithms, essentially?
Basically, step-by-step procedures, recipes almost, designed to solve a specific problem or show there's no solution.
And back to the AI effect, the successful ones just vanish into the background, like GPS routing.
Or airline scheduling, they just work, so we stop thinking of them as AI, they become utilities.
The book covers several types. State space search.
Crucial for planning. You map out possibilities. Think factory production planning, resource allocation, robot movements exploring paths from A to B.
And graphs, like a map.
Exactly. Nodes or locations, edges or connections. Like city streets, algorithms navigate these graphs.
Adversarial games sound interesting. Chess, go.
Right, where players compete. AI uses techniques like min-max, alpha-beta pruning to look ahead, anticipate moves, find optimal strategies. The War Games movie reference comes up too.
Right, the winning move is not to play. What about local search and heuristics for really complex problems?
Yeah, when you can't possibly map out every option. Local search starts with a decent guess and explores nearby options using heuristics, clever rules of thumb to find better solutions without exhaustive searching, necessary for really hard problems.
And these algorithms need serious computing power. How has hardware evolved?
Early AI hit the von Neumann bottleneck one operation at a time. Our brains are massively parallel. Multi-core CPUs help, but need special code.
The Harvard architecture tried something different.
Separating memory for instructions and data. Common in microcontrollers, adapted for things like DRM in phones or consoles.
But the real game changer for current AI seems to be the GPU graphics processing unit.
Absolutely. CPUs are generalists, GPUs are specialists, built for parallel math. Originally for games graphics, but the math is perfect for AI, especially neural networks. Hundreds, thousands of cores doing calculations simultaneously, much faster for these tasks.
Have there been even more specialized chips?
Companies have tried. IBM's Synapse True North mimicked the brain but didn't catch on widely. Google's TPU, Tensor Processing Unit, has been more successful, maybe fitting better into existing systems. Hardware keeps improving, pushing AI capabilities.
Okay, so bringing it all together, hardware, data, algorithms, we get back to machine learning and specifically deep learning.
Right. And machine learning lets AI tackle problems humans find easy but can't easily write instructions for, like recognizing a face, understanding speech in a noisy room.
The source mentioned different tribes of ML symbolic connectionist.
Yeah, different philosophies, historical approaches, symbolic, connectionist, neural nets, evolutionary, Bayesian, analogizers. They're sort of converging now, borrowing ideas.
Tell us about the Bayesian approach.
It's all about uncertainty. Updating beliefs with new evidence using Bayes' theorem. Starts with a prior belief, updates it to a posterior belief. Bayesian networks model cause and effect probabilistically.
And symbolic, more rule-based.
Yeah, complex rule systems derive from data.
Yeah.
Decisions are often explainable. You can see the rules. Older expert systems fit here. Uses induction learning rules and deduction applying them.
But central to the current wave is the neural network from the connectionist tribe.
Right. Basic unit is the neuron. A simple model of a biological one. Connect lots of them in layers, you get a network. The perceptron was an early limited version. Its limitations helped cause an AI winter.
How do they learn?
Backpropagation is key. The network makes a prediction, checks the error, and adjusts the connection strengths, the weights backwards through the layers to do better next time.
And deep learning just means lots of layers.
Essentially, yes. Many layers, sometimes hundreds deep, made possible by better hardware, big data, and smarter algorithms that fixed problems like, well, vanishing gradients.
Vanishing gradients, what's that?
Think of whispering a message down a long line. By the end, it's too weak. In early deep nets, the error signal got too weak, going back through many layers, so early layers didn't learn well. New techniques fixed that.
So deep learning is powerful, finding patterns humans miss.
Incredible for that. Drug discovery, medical image analysis, finding subtle things.
Me too. The book stresses it doesn't truly understand.
Critical point. It's pattern recognition and manipulation via math. It can interpolate, extend patterns within its training data, but it struggles to extrapolate to handle totally new situations or create truly novel concepts. Even experts sometimes describe it vaguely because it's just complex math, not easily explained human reasoning.
So it learns from patterns but can't invent genuinely new patterns.
That's a good way to put it. It's a pattern applying machine.
What about transfer learning? Sounds useful.
Very practical. Take a big network trained on, say, millions of images. Then you just tweak the last few layers to specialize it for a related task, like identifying pasta types. Yeah. Needs much less data and time than starting over.
And open source tools like TensorFlow and PyTorch made this accessible?
Hugely important. Democratize deep learning, letting many more people build and experiment.
The book also mentions specific types, like CNNs, convolutional neural networks.
Right, specialized for images. They use convolution filters that scan the image, finding edges, curves, then building up to complex features layer by layer. Revolutionized image recognition, like in the ImageNet competition.
But they can be fooled.
Yep. Add tiny calculated noise invisible to us, and a CNN might suddenly think a cat is a toaster. Shows they don't see like we do.
And Johnins. Generative adversarial networks.
Fascinating stuff. Two networks compete. A generator makes fake data, images, text. A discriminator tries to spot the fakes. They push each other to get better.
So they can create new content.
They can generate realistic outputs, yes. Used for creating training data, filling image gaps. But they have limits, especially with structured prediction.
Okay, so we have these powerful tools. Where do we actually see AI in action? The source says it's often invisible, millions of uses.
That AI effect again. When it works, it just blends in. It's everywhere.
Like fraud detection, that call from the bank.
Classic example. AI flags unusual spending patterns. Also, resource scheduling in hospitals, analysis helping doctors diagnose, factory automation handling unexpected hiccups.
Customer service chatbots, too.
Right. Though the book contrasts early simple ones like Eliza with modern ones and warns about bias, like Microsoft's Tay chatbot learning offensive things from Twitter.
Oh, right. Highlights the need for careful training data.
Absolutely. Controlled, supervised learning is crucial.
AI is also interacting with the physical world more now.
Through vision systems, hearing like voice assistants learning your voice, even experimental electronic noses for hazardous smells.
And physical interaction. Robots.
Beyond factories, Think self-driving cars, advanced prosthetics giving natural movement.
The Hugh Herr climbing example.
Yeah, incredible stuff. Surgical robots like Da Vinci giving surgeons superhuman stability, exoskeletons reducing workplace injuries or aiding mobility.
Health monitoring seems like a massive area.
Huge. Wearables tracking glucose, heart rate, sleep. AI helps manage health proactively, and diagnosis is being transformed.
The stats were incredible. AI spotting cancers faster, more accurately.
Up to 10,000 times faster analysis, higher accuracy, fewer false negatives in some cases. Life-changing potential.
Things like arteries for heart scans, butterfly networks, pocket MRI ultrasound.
Portable screening for kids in remote areas. Speeding up drug discovery like 3 scans, tissue analysis, Atomwise finding that Ebola candidate, even tracking medication adherence, saving billions potentially.
So it helps us understand our bodies better. What about communication?
Automated translation is common, though remember it's math and patterns, not true understanding, like the Chinese room argument.
Right, symbol manipulation.
There's also research into interpreting body language, tone. AI could potentially help bridge cultural barriers, but human nuance is tough.
Mobility is another huge one. Drones.
Started military, now everywhere. Recon, delivery, photography. Quadcopters use AI for stable flight.
But concerns remain about autonomous weapons.
Definitely. Musk, Hawking warned about the risks. That war games idea again, sometimes the best move is not to play.
And self-driving cars. An evolution, not a sudden jump.
Exactly. Levels of autonomy are increasing. AI assists for safety now. Social pressure to reduce accidents might speed it up.
Could change car ownership entirely.
Shared mobility, cars as offices. But it forces tough moral questions. The trolley problem. How does AI make life or death choices?
How do they actually sense and drive? Sounds complex.
It is. Hardware plus software. Sensing uses radar, LiDAR, ultrasound cameras. Each has limits, so sensor fusion combines them for a robust worldview. Localization knows where the car is, then AI plans the path and speed. Action systems execute the plan. Redundancy is key for safety.
Wow. Okay, shifting gears completely. AI in space.
Becoming essential for exploration and utilization. We're already manufacturing in space. AI helps plan trajectories, understand cosmology.
Well, it's helping create new science principles.
By finding patterns in vast data humans might miss. It's a partnership, like the Hidden Figures human computers. Space data needs AI analysis.
Space mining comes up to water, rare earths.
Potential resources, water for fuel, rare earths from the moon instead of damaging Earth mining. AI is vital for planning and processing in those extreme environments.
And finding new elements back here.
AI helps analyze particle accelerator data for fleeting new elements. And chemists used AI to predict millions of new crystal structures. Probes explore Mars, a key target. AI helps them identify interesting rocks, though scientists can always override.
Commercial space will rely heavily on AI.
For sure. Human missions to Mars in the 2030s will need massive AI support, but we need to be careful about conflicting parameters like HAL 9000.
With AI doing all this, what about jobs? Does it just replace people?
The source argues it enables new careers, maybe space baristas. But seriously, it's about human-AI collaboration. AI handles the dangerous, repetitive, data-heavy stuff.
Freeing humans for creativity, complex problem-solving, interaction.
Exactly. AI is an assistant, making us more efficient, letting us focus on uniquely human tasks. Creating new habitats, floating cities, underwater labs, moon bases that needs massive coordination.
Likely needing AI assistance for that scale of planning.
Are probably essential to manage that complexity. AI helping humanity expand by tackling these huge challenges.
Okay, so AI has incredible reach, but the book is really clear about tempering the hype. Where does AI hit its limits? What can't it do?
This is crucial. We anthropomorphize it, but it's technology. It lacks fundamental human traits.
Like creativity.
Yes,
Okay.
it replicates patterns brilliantly, mimics artistic styles. But it can't generate a truly new concept outside its data, not like Edison or Graham. It wouldn't make art from chicken wire spontaneously.
And imagination, conceiving the unreal.
Nope. Can't make those illogical leaps like the Wright brothers imagining flight. AI is grounded in its data.
Intuition, that gut feeling.
AI is logic and math. No direct perception of truth independent of reasoning. Can't make those intuitive detective leaps.
Which links back to understanding the Chinese room again.
Exactly. Manipulating symbols by rules, not grasping meaning. It can't understand intuition because we don't fully understand intuition.
AI solves defined problems. Humans handle undefined ones.
Big difference. AI needs clear inputs, goals, rules. Humans navigate ambiguity. ill-defined situations.
Can't tell fact from fiction inherently.
Relies entirely on its data. No internal skepticism. If the data is wrong, the AI accepts it.
And emotions. Empathy.
Cannot feel, cannot genuinely react to human emotions or navigate complex social situations requiring emotional intelligence. Judging an outfit, delivering bad news.
Limited senses, too.
Interacts via programmed inputs. Lacks our rich sensory world, maybe even subtle senses like magnetoception. Hard to measure or replicate.
And finally, AI cannot truly discover.
It interpolates, extends patterns within its data. Cannot extrapolate, create genuinely new knowledge outside its training. It can seem creative, but it's remixing known patterns, not true novelty.
So understanding those limits, what are some substantial contributions maybe flying under the radar, things with real impact?
Well, the source notes financial incentive drives adoption, but beyond headlines.
Active prosthetics.
Huge impact on quality of life. Remote patient monitoring, changing healthcare, saving costs. Medication adherence tracking again, huge potential savings, better health. Industry solutions are waiting for proven success elsewhere.
Right.
AI and robotics for dangerous factory work.
Right.
Assisting in creating new materials, new crystals, accelerating discovery. Helping us see the unseen microscopic, astronomical, non-visible spectrum data.
And addressing bias in AI itself is crucial work.
Absolutely. Learning from the Tay example, developing ways to ensure fairness and mitigate bias learned from flawed data is vital for responsible AI.
These contributions are real, tangible, supporting future goals like space exploration.
Exactly. The research drives technology forward, even if immediate profits aren't obvious.
But the source also highlights AI failures. Why do they happen?
Comes back to the same things. Overpromising, misunderstanding what AI is versus human intelligence, and relying on flawed or insufficient data or logic.
And failures have real-world consequences. Legal liability.
Yes, especially with autonomous systems or medical applications.
And let's just hammer home that core limit again. AI cannot discover or extrapolate.
It interpolates from existing knowledge, cannot create genuinely new knowledge outside its learned pattern.
And lacks intuition, understanding, empathy, comprehensive senses.
Those uniquely human capacities remain the biggest barrier.
Okay, so zooming out from this deep dive, we've gone from definitions and history
Through capabilities, applications both amazing and mundane.
to uncovering those fundamental limits.
The key takeaway really is that AI is an incredibly powerful tool. Data-driven, algorithmic, fantastic at pattern recognition, analysis, automation of defined tasks.
But it is not human. It lacks true understanding, creativity, imagination, intuition, emotional depth.
It's technology, not a replacement for us.
And the future the book points towards isn't competition, but collaboration.
Exactly. Human-AI collaboration. AI is the essential assistant handling routine, dangerous, data-heavy work.
Freeing humanity to focus on the challenges and creative work only we can do, requiring our unique intelligence and emotional skills.
Understanding the AI winter cycles, being clear about limits that helps manage expectations, avoid hype, and focus AI on making real progress where it truly excels.
It's about leveraging AI's strength pattern recognition, automation while letting humans thrive where we excel. Creativity, intuition, empathy, tackling the messy, undefined world. So we've seen how AI is both deeply embedded in our lives, often invisibly.
Yet still, in many ways, in its infancy compared to human potential.
It's a powerful tool for patterns and defined problems, freeing us from the mundane.
And we humans are uniquely equipped with creativity, imagination, intuition, navigating the complex, undefined realities.
So if AI excels at the defined, freeing us from routine, and humans excel at the creative and undefined, what entirely new frontiers of exploration and creation does that partnership unlock for you?